Hello and welcome to part 2 of our Objective 16 notes. Now, Objective 16, remember, says I can solve a system of linear equations algebraically and use systems of equations to solve real-world problems. And if you recall, last time we talked about solving systems with the method of substitution. We worked through that process. We did a couple, and then we also talked about the possibilities with how many solutions there were, whether there were one solution, no solution, or infinite solutions. And we talked about what that looked like, and then we did some more examples. Today what we're going to do is we're going to talk about another method we can use to solve systems of equations, and that's elimination. So let's start by breaking down how elimination works, what it really looks like, and let's go step by step here. So the first thing, elimination is all about eliminating a variable, so we only have one variable left. So what we're going to do, our first step is to identify the variable we want to eliminate. Now, looking at our sample problem to the right here, we can either eliminate x or eliminate y. And I'm looking here, and I'm going to choose to eliminate x. And the reason for that is I can see negative 3x and 9x. So what I'm going to do is I'm going to multiply one or both of the equations by a constant to set up for elimination. Now, what that means is I'm going to choose to multiply so that these either become the same value, like they both become 9, or opposite values, where one's negative 9 and one's positive 9. It really doesn't matter which one you choose, the consistency is what's key here. So I'm going to start by multiplying the top equation by 3. So I'm going to say 3 times negative 3x plus 2y equals 3. And I'm going to multiply everything in that equation by 3. So it'll become negative 9x plus 6y equals 9. My bottom equation stays the same, 9x minus 10y equals 5. And then the next step is to add or subtract the equations together to eliminate the desired variable. In this case, we're eliminating x. So would I add or subtract negative 9 and positive 9 to eliminate them? I would add, because negative 9 plus 9 is 0. So I'm going to add this together. I'm just going to do this vertically. Negative 9x plus 9x gives me 0x. 6y plus negative 10y gives me negative 4y. And 9 plus 5 gives me 14. Oh, interesting. So notice here, 0x, 0 times x is just 0. I'm left with only negative 4y equals 14. And I'm going to solve this equation for the variable. Notice we only have one variable now. We're just left with y. I'm going to divide by negative 4, divide by negative 4. This will give me a fraction here. We'll say y equals negative 7/2. Alright, so now that we've found y equals negative 7/2, we're going to plug in the value we found for that variable into one of the original equations and solve for x. So, looking at my original equations, negative 3x plus 2y equals 3, that's the smallest numbers, so I'm going to choose that one. Negative 3x plus 2, we know y is negative 7/2 equals 3. Now we're going to solve for the other variable, which is x. Alright, we're going to solve for x now. So I'm going to multiply 2 times negative 7, which is negative 14. Negative 14 divided by 2 is negative 7. You could also say those just divide out. Negative 3x, this will become minus 7 equals 3. Add 7 to both sides. Add 7. 3 plus 7 is 10. So negative 3x equals 10. Divide by negative 3. Divide by negative 3. And I find that x equals negative 10 over 3. Now we have x, we have y, but we don't have our final answer yet. We need to write that as a coordinate pair. Don't forget that, very important. So I would say my answer is negative 10/3, comma, negative 7/2. And that's elimination. Alright, so let's walk through it one more time. I start by picking a variable I want to eliminate. I multiply, in this case, my first equation by a constant to set up for elimination. I'm going to add or subtract the variables together to be left with only one variable. And then I'm going to solve for that one variable. In this case, we got y as negative 7/2. Once I have that, plug it back into one of the original equations, solve for the other equation, or for the other variable, excuse me, x equals negative 10/3, and then write my answer as a coordinate pair. Fantastic. All right, let's try some examples together. So looking at letter A, we got 2x minus 7y equals 16, negative 4x plus 7y is negative 4. So notice here, we already have, I don't know what that is, we already have variables that are set up to eliminate. If I have negative 7 and positive 7, would I add or subtract those together to eliminate them? Well, we'd add them. All right, negative 7 plus 7 is 0. So 2x plus negative 4x will become negative 2x. Negative 7 plus negative 7y plus 7y would become 0y. And 16 plus negative 4 is 12. So I'd have negative 2x plus 0 equals 12, divide by negative 2, divide by negative 2, and I find that x equals negative 6. Now that I know x is negative 6, I can plug that in. I have 2 times negative 6 minus 7 times negative 6 equals 16. 2 times, oh shoot, sorry, negative 7 times y. Silly me. X is only negative 6. Y is what we're going to solve for. So 2 times negative 6 is negative 12. Minus 7y equals 16. I'm going to add 12 to both sides. 16 plus 12 is 28. So negative 7y equals 28. Divide by negative 7. Divide by negative 7. And we find that y equals negative 4. So my solution then, I would have one solution. It would be negative 6, comma, negative 4. There we go. All right. Let's try letter B together as well. 7x plus y equals negative 17. Negative x minus y equals 5. Interesting. Notice I have y's that are already set to be eliminated here. I have a positive y and a negative y. If I want to eliminate those, I would add these equations together. So 7x plus negative 6x would become, or plus negative 1x would become 6x. Y plus negative y would become 0y. Negative 17 plus 5 would become negative 12. So I have 6x equals negative 12, divide by 6, divide by 6. Now I find that x equals negative 2. Once I have that, I can plug it in. I'm going to plug it into this bottom equation here. So I'd have the opposite of negative 2 minus y equals 5. So that's 2 minus y equals 5. I can subtract 2 from both sides. I'd have negative y equals negative, or positive 3. Divide by the negative 1 to get y all by itself, and I'd find that y equals negative 3. So my solution here would be negative 2, comma, negative 3. That would be my solution. All right, why don't you try letter C on your own? Go ahead and pause the video, try letter C, see how we do, and then we can check it together when you're done. All right, go ahead and pause, try letter C, and then we'll check it when you're done. All right, let's see how we did on letter C here. So notice 8x minus 3y equals negative 17, 2x minus 3y equals 7. If we tried to add these together, we'd get negative 3 plus negative 3, and that would give us negative 6y, which would not be very helpful. Instead, we need to subtract this bottom equation from the top equation. So 8x minus 2x is 6x. Negative 3y minus negative 3y is 0, right? Because subtracting a negative would become the positive. And negative 17 minus 7 is negative 24. So we'd find 6x equals negative 24. Divide by 6, divide by 6, and that tells us that x will equal negative 4. Now that I know that, I can plug that into either equation. I'm going to pick the bottom one. It's got smaller numbers. 2 times negative 4 minus 3y equals 7. 2 times negative 4 is negative 8. Minus 3y equals 7. Add 8 to both sides. 7 plus 8 is 15, so negative 3y equals 15. Divide by negative 3. Divide by negative 3. And I will find that y equals negative 5. So my solution then would be the coordinate, negative 4, comma, negative 5. And I'll box my answer, and there we go. All right. If you have any questions, feel free to raise your hand. I'll be around helping you out. Miss Kennedy will be around as well. Let's look at letter D now. So notice there's nothing here that's easy to eliminate. There's nothing that's already set for elimination. We're going to have to do some multiplying. And I'm looking at this and I see x. If I want to eliminate x, I could multiply the top equation by 4. If I want to eliminate y, I can multiply the top equation by 3. I think I'm going to do that one simply because it's a smaller number. I'm going to try to keep my numbers as small as possible in this process. So I'm going to multiply this top equation by 3, and that will give me 3x minus 6y equals negative 18. So now, since I have a positive 6 and a negative 6, I'm going to add these together. When I do that, I get negative 4x plus 3x. That will give me negative 1x. 6y plus negative y would be 0y. And 22 plus negative 18 would be negative 4. So I'm left with negative x equals negative 4, which tells me that x equals 4. Now that I know x is 4, I can plug that back into the original equation. So I'll have 4 minus 2y equals negative 6. So I'm going to subtract 4. My goal is to get y all by itself. So negative 2y equals negative 10. Divide by negative 2. Divide by negative 2. Negative 10 divided by negative 2 is 5. So my solution for this one would be the coordinate point 4, 5. Gorgeous. Love it. All right. Looking at letter E here. 5x plus 5y is negative 15. 2x plus 3y is negative 16. Well, notice there's nothing I can multiply 2, or at least no integers I can multiply 2 and 3 by to get 5. So this is one where I'm going to have to multiply both equations. All right, so I'm going to just try to eliminate x here. I'm going to multiply the top equation by 2, and I'm going to multiply the bottom equation by 5. Why would I do that? Well, that would give me 10x for both of these, and then I'll be able to subtract. So the top equation by 2 would become 10x plus 10y equals negative 30. The bottom equation by 5 will become 10x plus 15y equals, 5 times negative 16. Well, I know that 5 times 10 is 50. 5 times 6 is 30. So 16 would then be 50 plus 30, which would be 80. So negative 80 there. All right, now let's subtract these here. Since they are the same, 10x minus 10x will give me 0x. 10y minus 15y will give me negative 5y. And negative 30 minus negative 80. Okay, well, if I'm subtracting a negative, that becomes addition. Negative 30 plus 80 would become 50. Now I have negative 5y equals 50. I'm going to divide by negative 5, divide by negative 5, and I'm going to find that y equals negative 10. Now with that, I can plug this into either of the original equations. I'm going to pick the bottom one, smaller numbers. So 2x plus 3 times negative 10 equals negative 16. 3 times negative 10 is negative 30 equals negative 16. I'm going to add 30 to both sides. Negative 16 plus 30 would become 14. Divide by 2, divide by 2. 14 divided by 2 is 7. So my coordinate point would be 7, negative 10. That would be where these two equations intersect if we were to graph them. All right, let's do one more together, and then I'm going to have you try some on your own. Let's look at letter F here. Negative 4x plus 4y equals 4. 6x minus 6y equals negative 6. Well, I can't multiply 4 times an integer to give me 6, so let's multiply both of these fractions here. Now, what is a common multiple of 4 and 6? 12. So I can multiply this top equation by 3, the bottom equation by 2, and when I do that, I'm going to get negative 12x plus 12y equals 12. The bottom equation will become 12x minus 12y equals negative 12. All right, now notice, you might be able to tell what's going to happen here. I got negative 12x and a positive 12x. I have a positive 12y and a negative 12y and a positive 12 and negative 12. Well, in the sense of eliminating, I'm going to want to add these together. Negative 12x plus 12x becomes 0x. 12y minus 12y becomes 0y. 12 minus 12 becomes 0. 0x plus 0y, that's just 0 plus 0. Well, that's 0 equals 0. What does that mean? Think back to our last lesson. If we get a true statement with no variables, what does that mean? That means infinite solutions. So we can still get infinite solutions or no solution using elimination. It doesn't matter which method we use, we should be able to get that same answer. This one is infinite solutions. All right. If you have any questions, raise your hand. If you're feeling up to it, why don't you try one on your own? Why don't you go ahead and try letter G, pause the video, try letter G on your own, and then we'll check it together when you're done. All right, let's check how we did on letter G. Looking here, hopefully we saw that we could eliminate y if we multiply this top equation by 3. So that'll give us negative 21x plus 9y equals 3 times 22 is 60. All right, now the bottom equation wouldn't change. 3x plus 9y equals negative 30. Now since these are the same, we're going to do some subtraction here. So negative 21x minus 3x would become negative 24x plus 0y equals 66 minus negative 30 will become 66 plus 30, which is actually 96. Oh boy. So we're going to have negative 24x equals 96. To get x by itself, divide by negative 24. 26 divided by negative 24 actually becomes negative 4. So x equals negative 4. Now that I know that, I can plug it back into either equation. So I'm going to say 3 times negative 4 plus 9y equals negative 30. That is negative 12 plus 9y equals negative 30. I can add 12 to both. Negative 30 plus 12 is going to become negative 18. And when I divide by 9, negative 18 divided by 9 is negative 2. So my solution for this one would be the coordinate point, negative 4, negative 2. I would have one solution here. Negative 4, negative 2 would be where these lines intersect. All right. Hopefully we did good. If not, raise your hand. Let me know. We can find an error that we might have made. Otherwise, why don't you go ahead and try letter H on your own. Go ahead and pause the video, try letter H, and then we'll check it together. All right. Let's see how we did here on letter H. So I'm looking here. I see this 12x negative 4x, so I know I can multiply this bottom equation by 3. And that top equation won't change. It'll still be 12x plus 30y equals negative 22. But my bottom equation will become negative 12x minus 30y equals 18. And now I see, oh, this is going to be one where all the variables cancel out. I'm going to add this together. 12x plus negative 12x is 0x. 30y plus negative 30y is 0y. Negative 22 plus 18 would become negative 4. So I have 0x plus 0y, that's 0 plus 0. Just 0 equals negative 4. So this is an untrue statement with no variables. What does that mean? Hopefully we remembered that means that this system of equations has no solution. No solution here. These lines, if we graph them, would be parallel. They'd never cross. They'd never intersect with each other. All right, last one for today. Why don't you go ahead and try letter J on your own, pause the video, and then we will check it together. All right, so letter J you could have done a couple of different ways. You could have eliminated x by getting them both to equal like 12, or you could have eliminated y by getting them to both equal 6. And no matter which one you choose, we should end up with the same answer. I'm going to go to eliminate y here. So I'm going to multiply this top equation by 3, the bottom equation by 2, so that my y's become 1. The top one will be negative 6, the bottom one positive 6. So I'll have 9x minus 6y equals negative 27. I'll have negative 8x plus 6y equals 20. Now, I'm going to add these together to eliminate them. So 9x plus negative 8x will become 1x. Negative 6y plus 6y becomes 0. And negative 27 plus 20 will equal negative 7. So I find from there that x equals negative 7. Once I know that, I can plug that in. So I'll have 3 times negative 7 minus 2y equals negative 9. So negative 21 minus 2y equals negative 9. I'm going to add 21 to both sides. Add 21. Negative 9 plus 21 will give me 12. Divide by negative 2. Divide by negative 2. 12 divided by negative 2 is y equals negative 6. So my coordinate here, negative 7, comma, negative 6. Box my answer. And we're going to call that a day. All right. Hopefully we're feeling confident about elimination. If you have any questions, please don't hesitate to ask. If you're feeling good, go ahead and do the check for understanding that's up there on the board. Mr. Carter signing off. I'll see you next time.